we're going to be jumping back into looking at Python data types for a while now. So one of them is the set. And a set is a collection of unique objects. So unlike a list, all of the elements in a set have to be unique. You can create sets with curly braces or with the set function. And you can also do set comprehensions, which are like list comprehensions, except with curly braces instead of square brackets. Now sets have all of the methods and operators you'd expect them to, such as the union of sets, the intersection of sets, the difference of sets, and so on. And more information about them is available on the documentation. So we jump straight into an example here where we have vowels is defined as the set generated from a list of vowels. And so these are all unique, so we'll end up with a set that just contains A, E, I, O, and U. Now we have another example where we're using the random and string modules, which we saw in the last lecture. We're importing them here. And then we're using set comprehension, where we're getting random.choice from string.ascii lowercase, which is a collection of ASCII characters that are lowercase, and we're picking a random one for I in range 20. So we're doing that 20 times and we're getting a set of those. Now if I go ahead and run this, you can see we get the output. The random letters set contains blank unique letters, which is 18. So even though we did this sort of choosing a random letter or a random ASCII lowercase character 20 times, we only got 18 unique ones, which means we had a couple collisions, a couple duplicates. It contains these vowels. We're looking at the intersection of vowels and this set that we have. And it contains these consonants. We're looking at the difference of vowels and this set that we have. And of course, if we run this a few different times, you can see we get different output just based on the randomness inherent here. And so we get fewer, maybe more of these unique characters in this set. So we have an exercise here, which is a sort of fake password generator. And I say fake because if you really want something cryptographically secure, you'll want to use the secrets module in Python. And really, I'd recommend just using an actual password manager for this. But we're just looking to create a string of 10 random letters, numbers, and symbols. And if you want to get fancy, you could give your function an optional password length argument. So to go ahead and get started here, I know we're going to want to import random for some randomness. And we're going to import string because it contains some of these things like ASCII lowercase that we'd be interested in. And so let's just type string dot and look at what we can get from this. So we want random letters, numbers, and symbols. So maybe we'd be interested in ASCII letters. And let's just print this out for now. And let's actually see what type this is. Whoops, TYPE. It's a string, okay. So I know that I can add strings together. So maybe we'd be interested in, digits for the numbers and maybe punctuation for some symbols. So if I print this, now we have a pretty good starting point for our fake random number generator. Or not random number generator, our fake password generator, excuse me. And so we could use this random.choice that we saw to get a random value or random character from this string. So we could say our choices are this string, and each time we call random.choice on choices, we get some random character from that string. And so if we want to convert this to a string, maybe we use, well, we could do this a few different ways. As always, we could just say our password equals blank, And then we could say for I in range, say 10, just for now. Password plus equals our choice, and then we could print our password. All right, great. Now we could turn this into a function for our getting fancy portion of this exercise. So we could say def create password length. And then I'm actually going to get even fancier here and use an optional argument. Choices equals this, what we've been using, but that just allows users to set their own value. And so maybe we just indent this and say return password. And so then we can call create password with, say, 20. Oh, we need to set this to length. So now we can do a really short password, that's fitting, and a really long one, a really, really long one. So now we've created our not cryptographically secure random password generator.